Meet Chloe, a second-year medical student. She's on her way to the library to meet some classmates to show them a new educational service which allows collaborative sharing of the course material they have on their mobile phones and view it on an interactive table for enhanced group learning experience. Before she starts, Chloe explains how this technology works and how it can be useful in their anatomy course. Then, she picks up her NFC-enabled phone and touches the NFC tag on the table to connect to the backend server and transfer via Bluetooth a 3D model of upper leg, bone and muscle construction. Once the server receives the model, it executes a dedicated 3D viewer that displays the leg in full size. Chloe then illustrates to her colleagues the different interaction possibilities. In order to move the leg, Chloe moves 5 fingers along the surface of the table in the desired direction. To rotate the model, she slides 4 fingers on the table, which is then mapped to a corresponding rotation angle. And in order to zoom out the model, Chloe drags 2 fingers towards each other as demonstrated in the video. And to zoom into the model, she drags them further apart. In addition to this 3D manipulation of the leg on the table, Chloe can interact with its different parts individually through a side menu. She can tap the name of the bone or muscle of interest on the menu to highlight its location in the model. Chloe can disable parts of the 3D model, as done here for the femur bone, and she can even control the transparency of any of these to allow a see-through experience. Let's take a closer look at the technology behind this interesting service. The integral component of the application is the multi-touch table interface. It is basically a composition of various technologies integrated together into one box. There are 4 infrared lights in the corners of the upper part of the table structure. The emitted infrared light is reflected back into the box when the table surface is touched. The camera in the center of the box captures this reflection and tracks the motion on the surface. A projector is used to project the content to be displayed and interacted with on the table. The mobile phone used with this facility is NFC enabled. Chloe touches the tag on the table with her mobile phone to identify the Bluetooth address of the server to connect to. Once connected, the phone sends the 3D model data to the server in XML format, which is then parsed and rendered by the viewer application. The viewer is based on the OSG 3D graphics engine, which has been modified to handle multi-touch input from the table and simulate it in a single mouse-based interface like the one normally handled by the Windows system. This is achieved through integrating the TUI open source framework that defines a protocol and an API for tangible multi-touch interfaces into OSG. The model shown on the table is part of the 3D Anatomical Human project, whose purpose is to study the anatomical and functional aspects of the musculoskeletal system. As a case study, the research focuses on the lower limb and provides an anatomical model which includes bony tissues and soft tissues like cartilages, ligaments, and muscles. This 3D model can be coupled with other multimodal data like motion capture and soft tissue measurement to carry out advanced tasks such as gait analysis and knee joint physical simulation. Integrating 3D graphics, mobile phones, and multi-touch tables like in this application opens new doors for public interactive experiences that can engage multiple users at any time, anywhere, and allows knowledge sharing on the spot, creating as a result an immersive group learning experience.